For the given graphs of an equation, find the intercepts and indicate whether the graph is symmetric with respect to the x-axis, y-axis, or the origin. So the first thing we're going to do is we're just going to take a look at where the intercepts are. So the intercept simply means where I cross the x-axis or where my graph crosses the y-axis. Okay, so I can only see one here for the first one. So now it tells us to find the intercepts. So I'm going to label that as well. So that intercept is 0, 0. And that's my x-intercept and my y-intercept. Okay, now what it wants us to do is it wants us to determine if this is symmetric with respect to the origin, the x-axis, or the y-axis. So remember how that went. When I look at points on the graph, now remember any curve or line has infinitely many points. So I have a point there, 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 there. There's so many points on this thing. So just keep that in mind here. So essentially what I'm going to do is I'm going to pick a point. And can I shoot this through the origin and still be on the graph? And I would say, no, I can't do that. Can I shoot it across the y-axis and it be in the same place on the other side? It'll be over here. No. So that tells me there it's not symmetric with respect to the y-axis because this here is the y-axis here. So can I shoot it across the x-axis here and the same distance and I land in the same place? Or actually not the same place, but a part that's on the graph, a point that's on the graph. And I can. And no matter what point I pick, I will always be able to shoot it through that same distance and end up right back on the graph again. So what I would say for this problem here is I would say this is symmetric with respect to the x-axis. That's how we actually tell. Okay, so that's all I was told to do. I found the intercepts, the x and y, and actually that one point is both the x-intercept and the y-intercept. Because where my x is 0, that's a y-intercept. Where my y is 0, that's an x-intercept. And you can clearly see that that point is on both x and y-axis. Okay, so anyways, let's move on to the next one now. Okay, so now, if I put a point here at the top of this hill here, and I shoot it down that distance, that's a distance of 3, so I'm going to shoot it down here 3, and I can clearly see that point that would end up being there is not on the graph. So that tells me it's not symmetric across the x-axis. Because remember, this would be my mirror. So now let me take that same point and shoot it across the y-axis. And the point I get would be here, and that point is not on my graph as well. So it's not symmetric across the y-axis, or with respect to the y-axis. Also keep in mind it may be neither. Sometimes they're neither. Sometimes it's not the x, the y, or the origin. So that's an option as well. So now we're going to try through the origin. So now if I take this through the origin, just draw my dotted line, and I shoot it across to the other side. Oops, that's a terrible shot. Okay. And I see that I would end up back on my graph. And let's pick another point just to kind of get the gist of this. So I'll pick this point right here. And I'm going to shoot that right through the origin. And that same distance I'm going to shoot through the other side. And I'm going to be able to see that that is actually going to land on the graph. So no matter what point I pick, it's going to end up back on that graph again. So another way to look at it is if I took this piece right here and I just spun, or the whole thing I should say, and spun it around 180 degrees, I would end up with the same picture. If you can visualize that, that's good. If you can't, don't worry about it. I can always think of those points shooting through the origin. So this is actually a trick with respect to the origin. So now let's move to the last one here. So again, I'm thinking points. So no matter what point I pick, let's pick this one here. I'll stay off the actual axes. I'll pick this one here. Okay, and let me shoot it across now. I'm going to check for the x-axis, I guess. So that looks like right about 2. So I'm going to shoot through right about 2, and it's going to put me there. And I can see that it is going to give me a point on the graph. Okay, so I would say symmetric with respect to the x-axis. Oh, I forgot a main important point for my one even prior to this. I was supposed to label my intercepts, and I forgot about that. So let me go back to that for a second here. All right, so one thing I'll notice, and remember, it's where my graph crosses the axes. Either one of them. So here are my 3 points that I have that are either x's or y-intercepts. So this first one here, this is 1, 2, 3, 4. So 4, 0. And that would be an x-intercept because it's crossing the x-axis there. And I have this one over on the other side here, this one here. And that's going to be negative 4, 0, and that's also an x-intercept. And this one in the middle here, 0, 0, it's on both axes, so it's an x-intercept and a y-intercept. Now remember, when you have these x and y-intercepts, not necessarily on the graph, but when you're doing your work and you come up with them, or if it says, what are the intercepts, you should write them out. X-intercepts are these, y-intercepts are these. Okay, so that's that one. Sorry to stop the path on the last one then, but I wanted to make sure I get those intercepts in there. I should have waited till I was done with the symmetry on the other one. So anyways, so now let me just label these now, since we're here. So this here is going to be 0, 1, 2, 3, 4, 5. So this will be 0, 5, and that's a y-intercept. Okay, and then we have this one down here. That's not negative 5, it's 0, negative 5. And that's also a y-intercept. And then we have these ones here, this one over here and this one over here. Now this one here is 2, 0, and that's an x-intercept. And this here is negative 2, 0, and that's an x-intercept. So there they are. I apologize for that, guys. So anyways, there's my intercept. So now let's finish our idea here. Okay, so for the first idea, we can reflect across the x-axis. Now remember, that point is the same distance from the x-axis as the other side, and I'm still on the graph. So that tells me it's symmetric with respect to the x-axis. Now hang on a minute, we're not quite done yet. Now let's check this across the y. So now I'm going to take this distance all the way to the y-axis, and then I'm going to create that same distance on the other side of the y-axis, and I'm going to put a point there, and that point is also on the graph. And I can do that with every point here. If I pick this point, I would end up over here. If I pick this point, I would end up over here. In a very similar way I did with the x. The x would be exactly the same way. So this is also symmetric with respect to the y-axis. All right, so it's both. So now let's take a look at the origin now. So I'm just going to take this same point, shoot it through the origin. Now that distance, I'm going to shoot it out the other side. And guess what happens here? I end up on the graph again. So if you think about all of those points, no matter which one I pick, oops, if I shoot it through the origin, I'm going to get a point back on my graph again. So this is also symmetric to the origin. This graph is actually all 3 of them. So that just goes to show that it's not necessarily going to be one or the other. It could be all three. Could it be only two of them? Something to think about. Or it may be none of them. Okay, so there's our graphs.